problem 3.3, we want to write some functions that have the given description. And we're going to use graphing technology, I'm going to use Desmos, to help us make sure that our graphs actually work. So in this first problem, we want to do a first degree polynomial. So first degree right off the bat tells me that my biggest exponent is 1. So in other words, my equation must be y equals just a regular x to the first power, invisible first power. And I want this polynomial function to have a vertical, intercept the vertical axis. So that means my y-intercept of 8. Okay, well I know a first degree polynomial is actually just a line. And in order to have a y-intercept of 8, I must have that b part be a plus 8 at the end. I don't know what has to go out front, but let's just see if that works. Y equals x plus 8. I'll come over here and type that in. Let's see, so we have our first degree, that's plain old x, and our y-intercept is 8. So that one does work. Let's move on to the next one here. I'll get rid of this graph. A second degree polynomial whose graph has only positive y values. So second degree, that means my function must be x squared. Now if I wanted to only have positive y values, that means I know that it has to open upwards. It must look like this, because if it opened down, then it would definitely have negative numbers eventually, because it goes on and on forever downwards. So it must open up, which means I need to have a positive number out front here. Now, that positive number could just be 1, or it could be whatever I want. It could be 3, as long as it's positive. Doesn't matter. And then, has only positive y values. So let's see what that looks like right now. Y equals 3x squared. It looks like we pretty much only have positive y values, except for 1 right there. That has a y value of 0. So I need that to be positive. Well, I know I can move the whole graph upward by just adding a number at the end, right? Because this will change my y-intercept. So I'm going to put like a plus 5 here. Let's just test that to make sure. If I put on a plus 5 in my function, yeah, now our graph only has positive y values. It never goes down to the negative side. And we're good with that one too. Okay, a second degree polynomial function whose graph contains the point 0, -9. So second degree again. That means again I've got x squared as my biggest x piece, x term. And it contains 0, -9. Well, if it's 0, something, that's again a y-intercept. And I know that quadratics, their y-intercept, as long as they're in standard form, is just the constant number at the end. So I'm going to do x squared minus 9, and that should work. Let's just check that out real quick. X squared minus 9. And there's my point, 0, -9. So that did indeed work. Now I want to point one thing out here. I could have also done like x squared, plus 7x minus 9. The plus 7x does not change the fact that my y-intercept is still 0, -9. So that still works even if I put some other term in there, like a plus 7x or a minus 5x, right? It'll still work. I still have that 0, -9. Fourth one up, a third degree polynomial. So let's start off right there. Third degree means y equals x cubed, whose graph crosses the horizontal axis more than once. Crosses the horizontal axis more than once. Well, I don't really know how to get that to work, so let's just start off with x cubed. What does that look like? It looks like this. Well, that's definitely only crossing one time right now. Okay, well, what if I tack something on here? Let's put on like plus x squared. Okay, if I zoom in a little bit, I can see I cross once right there, I cross once right there. So this one already crosses the horizontal axis more than one time. Now you might argue that this is actually not really crossing right there, it's just kind of bouncing off of it. So maybe I want to change that up a little bit. Maybe I want to put something else in here, like minus 5x. What's that going to do? Let's zoom out. Now we're definitely crossing, boom, cross there, cross there, cross there. So this definitely crosses more than one time. So let's write that one down. X cubed plus x squared minus 5x. So we can kind of see as we add more terms in here, the polynomial starts to kind of move a little bit more usually, right? If I take out the minus 5x, less stuff going on. If I take out the plus x squared, less stuff going on. Okay, so we're done with that one. Last one up. A fourth degree or higher polynomial function whose graph never crosses the horizontal axis. So fourth degree. So that means y equals x to the fourth. And I never want to cross the horizontal axis, so never crossing the x-axis. Okay, well, first of all, let's just see what x to the fourth looks like. X to the fourth. Okay, well, that crosses, or at least touches the x-axis one time there. How can I change that? What if I put on, let's see, I know I can shift the whole graph up if I do plus something at the end, so let's do plus 3. Okay, well, now it looks like, let's zoom out to make sure. It looks like our graph is never crossing the horizontal axis, so that's good. So x to the fourth plus 3 seems to work. Now I want to try one other thing here, because it said fourth degree or higher. Let's try x to the fifth. Now this one's not working, because this one does cross. It crosses right there. And actually it looks like this fifth degree polynomial goes down forever and up forever if I zoom out a lot. So it seems like no matter what I do at the end here, minus x squared plus 4x, right? No matter what I do here, I'm going to have some difficulty making this never cross the x-axis because it goes up forever and down forever. So that one just doesn't seem like it's going to work. But if I do x to the fourth, then I can pretty easily, because it goes up forever only, make it so that it never crosses the x-axis.